Okay. Welcome to this lightning talk where I'll present how we are enhancing our data platform here at Pinterest. This is a follow-up talk to a talk my manager gave at VeloxCon last year, and I will share some of the improvements we've done since then. We are very committed to using Gluten and Velox on our platform because we are seeing good performance results, and some of them I will share today. So this is the agenda. I will give a small overview of our platform and what we're running, and I'll explain why we picked Gluten and Velox and what the platform integration work we've done so far. Then I'll share some performance improvements we are seeing for our ad hoc workloads, and I'll also share some of the challenges we are facing integrating Gluten and Velox into our platform. I'll wrap it up with sharing our future plans. About me, my name is Felix. I'm a software engineer on the Big Data Query Platform team at Pinterest. We own two major services at the company, Spark SQL and Trino. And today we'll be focusing on our Spark SQL platform. So our platform, we run more than 25,000 scheduled jobs and more than 8,000 ad hoc jobs every day. Our entire fleet consists of more than 15,000 instances, and we have more than 500 daily active ad hoc users. With our partner teams, we're currently in the process of migrating our cluster to Kubernetes away from Yarn, and we use Caliborn as our shuffle service. Most of our jobs are entirely SQL-based, and most of them are running on Spark 3.2 at the moment. So why did we pick Gluten and Velox? We're seeing increasing job requirements from all our customers. This is driven by increasing data sizes, more complex jobs, and a lot more machine learning workloads. Often, our clusters are memory bound, so we are looking for ways to alleviate that memory pressure, and native execution has shown large gains in a lot of data systems, so we want to take advantage of them by integrating Velox into our existing Spark infrastructure using Gluten. What was really important to us is that the integration should be easy and seamless, and we can start upgrading jobs one by one. That's the case with Gluten because we can just build a jar and distribute it to the jobs, and then we manage all the configurations on behalf of the user. They just have a simple configuration that they can turn on and off. We're also very excited by the fast-moving open source community that always keeps improving the project. And we're also very happy that it's supported by large companies like IBM and Meta. That gives us a lot of confidence in the future of the project. To integrate Gluten and Velox into our platform, we have done a few things. One, every compatible ad hoc query is automatically using Velox by default now. We achieve that by checking for fallbacks to JavaSpark on Livy. That's our job submission system for ad hoc workloads. This is achieved by running an explain on the query, and only if there are 0 fallbacks detected, we are enabling Velox for that query. That's something that we want to explore more if we can tolerate certain fallbacks while still seeing better performance, similar to what mentioned in earlier talks today. The configuration management for our users is integrated into our custom Spark build so that users can just set a simple config and don't have to worry about what memory config to set and enable RFeed and a variety of other things. It also works in our Airflow operator that a lot of our customers use. And we started onboarding some scheduled jobs with experienced customers that are owning very large jobs. There's currently no fallback check on scheduled jobs, as there's no Livy host that could run an explain session and check for fallbacks. Also, while we are migrating our cluster to Kubernetes, we also started migrating to Caliborn as our shuffle service. And Gluten had support for that early on, so we did a bunch of validation and performance testing work to make sure that it works nicely. We also, within the team, built a sampling and testing framework so that we could run our production jobs quickly and validate rebases and fixes more effectively. So performance benchmarking. During last year's presentation, we showed a performance benchmark where we tested the heaviest queries on a dedicated cluster. So there was no other queries running except the one query that we wanted to benchmark to reduce noise from other resource usage. So the goal of this test was to quantify the maximum possible gain that we could see in like the best case. And we saw an average improvement of around 70%. This is an evaluation we did last year. As you can see, most of the jobs improved by 25 to 50%. But it's important to note that this evaluation was done over a year ago. So a lot of fixes have been made and performance has been improved a lot. But this made us very confident to continue this path to enable Gluten and Velox for more of our jobs. So what I'm sharing now is the performance we're seeing on ad hoc workloads. It's a comparison of real ad hoc traffic that we're seeing. Just have to keep in mind that we're only enabling Gluten and Velox for queries that have 0 fallbacks to Java Spark. So around 30% of our queries are currently compatible. This number is usually higher for ad hoc queries because UDF usage is not as common there. The first metric I'm showing is like elapsed query time. This is an important metric for our analysts because it measures how long it takes for them to get the data back that they need and directly relates to analytical velocity. As you can see, the orange line shows Gluten elapsed time. The median time we're seeing for our ad hoc workload around last month for around 2 weeks was 150 seconds, where the non-Gluten workloads that used just Java Spark were closer to 250 seconds most of the time. So we're very happy with that improvement because it really helps our users get their work done faster. But as I mentioned before, one of our main concerns on our clusters is memory usage. We are often bound by memory, so we wanted to see large gains in memory used when using Gluten and Velox. And this is what we're seeing around the same time frame. This is the median memory that is used on the executors. And you can see a very large drop where the memory used in Gluten is 2x reduced compared to Java Spark. This is really important for us to alleviate memory pressure on our clusters and allows us to right-size our executors and shrink them in size. This will make queries faster and also save us cost. Obviously, when integrating a new project into a big existing platform, there are like learnings and challenges. One thing that we are still actively investigating is we're seeing heap memory usage during broadcasts, even for fully offloaded queries. Also, in the past, there was an issue doing sort-based Caliborn shuffles due to some implementation issues. We worked with the team at IBM, and we are currently testing a fix for that. And this shows like the great collaboration in the community, and we're very happy about that. We also realized that we need to have better ways to collect fallbacks to Java Spark at scale to better drive our development direction. We need to know what are the most common fallbacks we're seeing so that we can tackle these first. This leads us to our future plans. Our overall future plan is obviously improve compatibility with queries. Currently, only fully offloaded queries are automatically enabled, and therefore we want to increase compatibility so that more and more queries are enabled with Velox by default, and we're seeing the performance savings. One big thing that's been mentioned before today many times is UDFs. We're also seeing the same issue that we would need to translate UDFs to C++, which is expensive and difficult in some cases, but it's something that we want to take on for our most important workloads. And then the other approach is, can we still run Java UDFs in a more performant way, as described in the talk just before me? A company-wide effort is to migrate important data sets to columnar formats like Iceberg. This will also give us performance improvements and Velox compatibility increases to formats like Iceberg. It will also help other query engines as well, but it's very helpful for our Gluten and Velox adoption. I mentioned the fallback check we're doing to Java Spark, and we're currently doing that on Livy, on like dedicated submission system. We want to move that fallback check into the Gluten plugin itself, where it performs a fallback check. And if there's a certain number of fallbacks detected, it could release the off-heap memory that we assigned to it and just run the query as a regular Java Spark query. We are making use of stage-level resource profiles, which is exciting work that's happening in open source. And we will continue to evaluate it for different use cases to optimize our resource usage. Also, I mentioned that some select teams are onboarding scheduled queries, and we want to have an automated way to do that on behalf of our customers. And the fallback check within Gluten is very important to onboard these scheduled jobs. As part of the Gluten roadmap is improved ARM support, and that's something that we also want to focus on this year to see if there are any cost savings that we could take advantage of. Last but not least, frequent benchmarking and rebases are very important for us. The project is moving fast, and that's why we created the sampling and testing framework, so we can validate changes against sampled production jobs easily and effectively. We wanted to say thank you to Binwei for all the support he's provided us for in the last year. And I also wanted to say thank you for every team member on the Big Data Query Platform team for their work that I had the pleasure of sharing with you today. Thank you. Feel free.
There you can use.
Can you elaborate on the shuffle service OOM issues? So we are seeing a lot, I mean, as compared to Vanilla Spark, we are seeing a lot of shuffle being done here in while using with Velox and Gluten.
So it wasn't specific about like the usage of shuffle service, but some queries there was high memory usage when using Caliborn shuffle service, and it was due to the implementation being not optimal. There's some fixes that are I think already emerged in open source that we are testing, and that should alleviate the issue.
Hi. You mentioned zero fallback check is very important for your queries. Can you elaborate why? Like you may get like 50% benefit even if there are some fallbacks, right? Why is that not acceptable?
So the problem is that we don't know if we have a fallback, if the performance is good. We don't have like very advanced heuristics yet that tell us if like we could still see better performance even if we had some kind of fallbacks. So currently we have zero fallbacks because we'll see much better result, and we won't see a regression in performance or memory usage. But that's definitely something we want to like explore further, if we can tolerate some number of fallbacks or certain kinds of fallbacks.
Thank you.
I was just curious, like you showed the performance improvement bar chart, right? And is there any like regression? And did you try to see if there's any reason?
I think I know what you're referring to. So this is ad hoc workloads, and that was on the weekends. We're seeing a lot less traffic on ad hoc workloads, so the data is a lot smaller. So there's more variability in what single queries can skew data a lot more. Some jobs, as analysts usually don't submit as many queries on weekends.
Yeah, but for general, like when you integrate all this, there's no regression, like in performance.
There's no regressions when we don't have any fallbacks.
I see. Thanks.